to the desk of Ladyada.
Hey everybody, it's another week and time for another Maker to Market video. This is a Maker.io release collaboration between us and DigiKey, where we're doing a video a week, like about an hour long a piece, about how to take your Maker design and bring it to market. That's what we're doing.
That's right. So far, we've covered concept, research, evaluation. Tonight is design.
Yeah, it has been a journey. We went from what's the basic idea behind Circuit Playground, that's the product that we're going to be designing, all the way to the end here, what we were looking for, and then we researched a lot of other options, what components and what capabilities we wanted to have in the circuit board. Then we did evaluation, where we actually started speccing out components, ordering eval boards, trying them out, making sure that the microphone sensor we got is a good microphone sensor. And then now we're up to design. This is actually where I have the most fun. This is where we actually start to get to lay out some circuit boards.
That's right. And on the Maker.io site, in the design section, now that you're finally ready to move forward on your project, it's time to really begin the creative process. Hi, that's me.
Hi there.
I'm over
Hello.
here. Spend time drafting your electrical and mechanical design, selecting components, and laying out technical specifications. Lay out your PCB and initial bill of materials, and finalize your platform. Expect to spend a little money here. Evaluation kits and prototype components aren't free.
No, they're not.
All right.
But they're not too bad.
Yeah, so Ladyada, when you hear about design in PCB land, before we even kick it off, I guess, what tool do you really like to use?
Well, I've always done my PCB CAD layout in EagleCAD. And I always tell people you can pick your poison. It really doesn't matter too much which PCB software you use. If I was starting out now, I would probably learn something like KiCad, which is a free open source cross-platform PCB and schematic capture tool. Just so happens that 10 years ago when I looked at KiCad, it was still very early in development. It wasn't quite ready for the kind of boards that I was making, and so I ended up using EagleCAD because that's what kind of everybody at the MIT Media Lab was using, and so I used the MIT Media Lab site license because it was free.
Yeah.
And so when I graduated, it was like, well, I should just pick up my own personal license for EagleCAD, and that's what I did.
And there's a bunch of online tools as well. And Eagle was just purchased by Autodesk.
Yes,
so
right.
it too may be an
It will
online
probably,
tools.
yeah, it'll
And
probably
then
become online.
If you go to a lot of the electronic sites, including DigiKey, there's Scheme.it, and there's a lot of ways. So
you can use online tools as well. I just have not got a lot of experience with
Yeah.
them. I really like, I'm just like, I use this. People use like Altium, they use OrCAD, they use PCB Express or PCB 123 or like Scheme.it or Upverter. You can use Fritzing to design very basic circuit boards.
Maybe you could tell folks it doesn't matter.
It doesn't matter.
Because that's one of the things that I see a lot of people ask, like, which tool should I use? Like, it probably doesn't matter.
It doesn't matter for the kind of boards that most makers are making. If you are doing 8-layer boards and you have to do impedance matching on them, and you have to have match traces, there's some tools that don't do that, so you'd have to do it manually if it wasn't done by the tool. It doesn't mean you can't use those tools, it just means it's going to be a little bit tougher. I mean, like we sent people to space with like hand-drawn PCBs. So I mean, it's all possible. Again, use whatever tool you want. They're all going to be very similar. There's going to be the schematic version of your circuit that you usually draw first, and then you do the layout version second, where you actually fit it and route all the traces.
Okay.
Either way, as long as it generates Gerber files, you're pretty much good to go, and nearly all of them do.
All right, so let's see some Circuit Playground. What do you want to start off with?
Okay, so let's go to my desktop, and we'll just review really quickly what we were doing. All right, so we're at the design phase. So selecting components. We selected some components in the evaluation phase as well. And as you do your design, it's funny, this is like design. It's like, one circle, but it really isn't. This is a very fluid step where you're going to go back to research, evaluation, and then even back from prototyping, back and forth. As you're speccing components, you're going to look at what other people did. That's part of your research. You're going to maybe determine that some of your components don't match the specification that you want, find other ones, maybe a part that you want isn't available. So you'll have to revisit. Actually, I was just evaluated a really nice UV sensor from ST, and I got samples and I tried it out, and I was like, this is actually a really nice sensor. And then I went to order it, and ST said, you know what, we actually couldn't manufacture this part with the yields we wanted, so we've basically discontinued it. They actually aren't going to make the sensor that they said they were going to. That happens.
So
that happens sometimes.
When that happens, did you get a notice in advance, or is it just when you went to order it?
There's no notice. No, usually, if you're buying a part that's already in manufacture, you'll get a notice. But because this was a pre-manufactured part, I'd only gone engineering samples. Again, I've never had a situation where I ordered engineering samples and the final, component never existed, but it has happened.
Can you think of another kind of example that burned into your head? Is there a past part that you remember that you were using or about to use, and then it was yoinked away from your design?
There's definitely been components where you have extremely long lead times, longer than expected. This is where going to the DigiKey site and making sure it's in stock and seeing what the stock numbers are, and if they have lead time. And DigiKey will actually, if you call them, you'll say, hey, what's the lead time for this part, they'll tell you.
Yeah.
And that's really important, because if you have a really great part but the lead time is 16 weeks, your SOL, I remember Particle, they were about to release, they were manufacturing their Kickstarter photon board, and the the buck converter chip that they picked, it was a micro 3.3 buck converter.
Yeah.
Suddenly it was a 16-week lead time, or it was there was some variation in the part that they weren't expecting, and so they actually, it's a good idea to have alternatives. Spec alt parts. I always recommend it if you can do it. I know it's there's always, it always seems like there's only one part that will do the job, but if it's possible, get an alternative. It's going to be easier for things like transistors and op amps, and of course, resistors and capacitors and other passives aren't as important. But for connectors, those can be long lead time. These are things that you want to work into your design, because after the design phase, it's very hard to go back and undo decisions. So think about, what if this part, for every part that you put down, what if this part suddenly disappeared? It's okay if there's a more expensive version, because more expensive, at least you'll get to market. But if there really is no alternative, think really hard about whether you absolutely need that part. If you save a cent, but there's no equivalent, then you screw yourself.
Are they
later.
often drop-in replacements, or sometimes you need to rework the board?
It depends. Some things like a voltage regulator, or an op amp, there's kind of a standard pinout for, a SOT 23.5 regulator. We have one that I've actually switched. We used to use a TI part, then I switched to a Micrel part, and then Micrel got purchased by Microchip, and suddenly it was very hard to get that MIC 5225, and so I've got an alternative, the AP2112. So it's good to have a couple options available.
Yeah, and one thing, the consolidation in the electronics market does disrupt supply chains. It disrupts everything. We were talking to a large chip company, and they couldn't approve a marketing graphic for 8 months. They still haven't, because they got acquired.
Everybody's getting acquired.
And they're
now.
we can't really do this right now because we got acquired. It's wow, a graphic. And it was really nothing, it's still nothing that's significant. It's just a graphic to promote a product, and they couldn't approve it because they have too many people, too many acquisitions, too much going on, and it's just kind of a mess. So
anyways, alts.
Alts
are good.
Alts for everything.
Alts for everything.
Okay.
Again, if the main chip we're using, the Amiga 32U4, there's no alt. There's only one maker of that particular chip. But if you are going to a large-scale manufacturer, and it doesn't matter too much what processor, it might not be a bad idea to make sure that there are other processors that could do the job. You never know, really. I remember a couple years ago, during the 2008 financial downturn, there was 16 to 22 week lead times for latches. We're talking about generic jelly bean parts from TI, and it was 16 to 22 week lead time. It was insane.
I remember when Planet Earth weather was getting intense. I think not too long after that, and all of a sudden, parts that you thought were going to be coming in, nope. So
it happens. Anyways, something to think about in design. Just like you design for testing and for manufacture at this stage, keep this stuff in mind because you will get burned. You can easily get burned by this later.
If you're a single product company, I think it's even worse because your entire company is centered around one product. We have 3,000 products, so if there's delays or something like that, the show continues. But if you're just launching one product, you're a Kickstarter, Indiegogo, Crowd Supply, whatever it is, funded company, which is one product, it's even more critical.
And as you know, later on you'll go to the funding and production side, but if there is a part that's critical, be prepared to purchase that entire amount you need for a full year ahead of time.
Yeah,
like you may be able to, it could be very expensive. Yeah. You might be able to do certain things like bonding, but it's hard to do that if this is your first product. Like you're not going to be able to get like credit.
Yeah. You have to be a player.
You have to spend a little bit more money so people are like, well, it's worth taking a risk on you. But be ready for anything that you see here. Check the lead times. And pick your parts because once you lay out the board and then you take it through certification, it's very hard. It can be hard to go back and reroute the board, and then you'll have to redo your certifications. Maybe not so bad, but it's something to keep in mind. Can add up a lot of in scrap costs or
so now that we
reworking.
Scared the heck out of you.
I know that was a little scary.
No, well, I'd rather. You know what? Again, I've said this in every video. I've not seen a single video series that talks about anything like this. I've seen a lot of like, so you want to make hardware? Well, send it to China. Like that's every video I've seen recently. And it's just like, okay, that's completely useless information or advice. So what do you want to start doing first?
Okay, so let's go back. So we at the last episode we started budgeting out our bill of materials, and we picked out components that we were going to use for all of this, and we kind of came up with the list of items that we wanted to put in, and we sort of said, okay, well, we kind of hit our budget, so that's good. And this list of parts will of course vary with your design. You may end up not being able to use a 20-cent JST. Maybe you can use a 5-cent. Maybe you need a 50-cent. So let's go. Can we go to the overhead briefly? Mm-hmm. So we were talking about what we wanted this to look like, and in the end, we actually sort of thought like, well, let's make it sort of like the Flora, because it's the Flora is an educational microcontroller that this is the version 1 and a version 2. There's large boards like the Flora, but we decided like, well, we wanted something much smaller, something wearable, something more portable, even though this is a really cool design. So looking at the Flora, well, I actually was like, well, this is something that's worked out for us. So let's make something that is pretty much, compatible with the Flora, but just like maybe a little bit bigger, or as small as possible. And in particular, I liked the Alligator Pads and a circle around it, because if you're going to have Alligator Pads, it's not going to be breadboard friendly. But again, that's one of the specifications that we came up with in the first episode or second episode. We don't need it to be breadboard friendly. I'm perfectly happy with. Grab some alligators.
So I've got a question.
Alligator clips, yeah.
I don't know which one this falls into, but Alligator Pads. So these are finding their way into an existing product, which is the latest version of Flora, because Circuit Playground had it first. Yeah. And now you're looking at the benefits of that.
But you could still do it with the first version. It was just not, it was just like, oh, these could slip a little bit more.
And then show that this is the latest version.
Yeah, this one you can really
Flora.
Clamp down on it.
So the things that you developed in a later product, you're now adding to an earlier product. That's kind of cool.
Yeah. Crazy.
That's kind of neat.
Yeah.
Yeah, like we learned a new trick. We also have a Neopixel on the Flora.
Yeah.
And then later on, a later design is a Circuit Playground, and there's a bunch of Neopixels. Yeah.
Okay, so let's go to Eagle CAD, and I'll start showing kind of how I laid it out. But then just be aware, I'm not going to lay out the entire circuit board because it actually takes quite a few hours. So let's go to Flora, and I will I'll just open the Flora board to give you an idea of, this is what circuit boards look like in CAD programs. It's very, blue and red, and every layer means something. So I'm going to sort of like start with this, and I'm going to gut it. I mean, this is open source hardware, so that's okay. You know, you can take one of my designs and whip out what you don't want and just keep what you do want. So to start, I'm going to rip up, take out all the traces, and I'm going to hide the silkscreen and the top stop and the bottom stop. And then I'll hide the back silkscreen as well. So this is the design for the Flora, and you know, it looks a little bit like the design. It's round. This is, you know, a computer model of it. Hey, there's a cat. Cat's coming in to help design. But I need to minimize how much stuff I've got going on here so I can fit more of the sensors. Remember, the Circuit Playground is kind of like a Flora, but with more. So for example, this chip, which was a TQFP, meow. Oh, he wants to come and say hi.
All right.
Oh.
Not black cat not required for Eagle CAD, but it helps.
It really helps.
Yeah.
Say
all
the
right.
cat hi. Meow, meow, meow.
All right.
Well, he came by here, so
Yeah.
that's what he wanted. So this part is a TQFP, but I want to change it to a TQFN. So you can check it out. If you look up at Mega 32U4, this comes in a couple different packages. Manufacturability does vary a little bit with package. BGAs are going to be a little harder to manufacture than QFNs. QFNs are going to be a little harder to manufacture than TQFPs. But in general, I would go with all surface mount if you can. What's interesting is actually the QFN version is a little bit cheaper than the QFP by, you know, a couple cents. But, you know, whatever, every penny counts. So, oh, you know, this is, let me, I don't know if I have the package. Here, hold on, let me, one of the things that you'll do when you have a lot of components, as you'll create like a library. And in this case, I have a different library with the component that is the QFN. Yeah, it's right here. So in this case, the microbuilder library, which is what K-Town and I use, we have a TQFP version, and then think a smaller TQFN. You can see the scale here to show you it's, you know, half the size or a quarter of the size. So we'll use that instead. So I'll show you how much we save in space. Wow, so much smaller. So that's kind of nice. And then we'll get rid of this old version. And then a couple other things. So I'll get rid of this silkscreen for now. And okay, so then there's this programming header. And you do need to have a programming header. But in this case, I'm going to make the programming header appear as dots on the bottom of the board. So instead of having a 2x3 pin header, I'm going to grab a test point. And test points are awesome. You should have tons of test points. Think about what test points you want to have, because it's really hard to add test points after the fact. It's really easy to add them during the design phase. So see all these test points that I added? Now I can have these basically in the same location, but on the back of the board. And that means that I don't have to have this large through-hole piece, because I'll just use pogo pins, little spring pins, to touch the touch pads. If you look on the bottom of a lot of products, you'll see touch pads. So maybe I'll show the touch pads. Can you go to
Yep.
overhead? So on the Flora, you know, it was an older design. I was like, oh, I'll make these through-hole pads in case people want to solder on an ICSP header, the programming header. But with Circuit Playground, I'm not expecting people to program it. So these pins are on the back, and they don't come on the front. They're just on the back. And I use a testing jig, which I'll show later. And when I test it, the little nails come and touch these pads to program it. But saves you a
You're
little bit of
designing
space.
for manufacturing.
We're designing for manufacturing. It's
Before
part of the
we
process.
go back to your computer,
Yeah.
because someone had asked on another video, can you show the Circuit Playground? the back side of it.
This is the
No,
prototype.
the other one. Right. Oh, sorry, the Flora.
The Flora.
So on the Flora, it says C with a circle. That's not copyright, folks. Just to be super duper clear, that's a revision.
That's my revision code.
We had a B and we had a C.
Yeah, Rev C unfortunately looks just like the copyright,
Yeah.
but this is.
When we get to Rev C, we copyright everything. No, anyways, that's what it means.
Yeah, because here you can see this is Circuit Playground and C
Yeah.
to B here. Put revision codes on your PCB so
Yeah,
you know
it's
what
a neat
PCB is.
trick. Just don't freak when you see if we ever get to revision R or
Yeah.
C.
So yeah, you can see I actually made these little pads get a little bit bigger
Yeah.
here. But yeah, those are the programming pads. Okay, so let's go back to the compy.
Okay.
Okay, so this, let's get rid of this. So one thing I'm going to do is most of the power supply is actually very similar to Circuit Playground and Flora, but I'm going to change my component sizes because all of those components are 0805. Depending on your soldering scale and how much space you have, you can choose 0805, 0603, 1206. That's the size in mils, thousandths of an inch of the component. And just stick with one because it'll make your life easier if you just have like one size. It's hard to solder 0402s and do rework. I don't recommend using anything smaller than 0603. I find 0805 to be a good balance. If you're really new at surface mount soldering, 1206, but 0805 is pretty good. Since Circuit Playground is going to be like totally machine manufactured and the machinery we have can do it, I'm going to go with 0603. So I'm going to change the packages. You can see we have a whole list of packages. I'm going to go with 0603. So the part just shrank. So you see how this part is smaller than this part. And
Look
you
at
can go.
all the space you're saving.
I'm saving space. I'm like that Japanese woman who's like, hold the component to your heart. And
Yes.
if it gives you joy, you can keep it.
Yes.
Yeah, we have all sorts of different, we have a version with like an outline and a version without an outline, and we have a version that's a little bit smaller. So, you have your own favorite collection of components to match your manufacturing. You can check the IPC soldering standards. There are, at IPC, like they have a standard for the footprints, and I would suggest following them if this does come through ever. Anyway, search for soldering standard, and there are sites down, but you can find various. Oh yeah, so the land pattern calculator. So this is kind of handy. You can use it to calculate. You download it and install it, but it's a piece of software that'll tell you the size of the lands. That'll minimize bridging and tombstoning when the component picks up. So this is part of your design process as well. Okay, so we're gonna tighten up some parts here. So like for example, I'm gonna put the power supply diodes over here. I'm going to change a little piece of the design. For example, the on-off switch is going to be a generic. All these parts got twisted. I'm going to have the on-off switch not be an on-off switch. The on-off switch will actually be just a generic switch. And instead, there's not going to be an on-off switch because, I'll tell you why. I thought about like, do I need to have an on-off switch for the design? And with the Flora, I thought people use the Flora with li-poly batteries. But since the Circuit Playground isn't going to be shipping with li-poly batteries, we're going to ship it with our AAA battery pack. So go to... And the AAA battery pack has an on-off switch on it. And so because of that, I was like, well, I don't need to have an on-off switch on the board. I think I can get away with not having that. I'm also removing the fuse that I put on. And the reason for that is pretty much every USB device is fused these days. And moreover, like all of the current's going to go through the 3.3 volt regulator. So I'm not really as worried about shorting something out. So the switch is going to end up being kind of a generic switch rather than a like it's a switch for the user, not an on-off switch. And I ended up kind of putting it over here. And then I ended up kind of tucking the voltage regulator like, I think like around here-ish. And then, you know, you can move your components around later as necessary. Oh, you know, I'm going to remove, I had a voltage divider that I'm going to remove. Bam. Okay, another thing is there's RX and TX LEDs on the circuit playground, and I'm actually going to just not use those. I decided I'm not going to include them. I ended up not having enough space in my final design, so I'll just take them out. I did have an on LED and a pin 13 LED, and I thought like those are pretty good. I think those are fine to stick with. Okay, so this is kind of coming together. And so I wanted to put Neopixels all around it, but I wanted to have at least like 10 Neopixels, and this size is way too big. So luckily we have a mini Neopixel version. Mini Neopixel. And, well, sorry. And they come with like a black plastic cover, which is kind of nice too. And compared to normal Neopixels, are about half the size. They're 3.5 millimeter by 3.5 millimeter, so way smaller. And I actually used them for a little bit in another product, the Neopixel Feather Wing. So having manufactured with this component already, I knew that I was going to get, oh no, hold on. Okay, it didn't crash. No, it crashed. I can't do this much stuff. Having manufactured with this component meant I knew that the yield was pretty good. Some LEDs, you can have kind of iffy yield. Just be aware of that. Like, you know, if you have one component that has bad yield, it doesn't, especially LEDs, they sometimes crack during manufacturing if you don't desiccate them properly and dehumidify them. Just something to watch out for. But it turns out that this component, actually, I had no problems with manufacturing, and so I can change the package to be a much smaller version. So you can see, wow, like teeny, much, much smaller. And this is kind of a mess right now, but just bear with me. I'll delete this frame. And we're going to put in 10 of these. And they chain, which is really nice. You only have to use one pin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 Neopixels. So sweet. You know, I can kind of start thinking. I wanted them to be sort of like a Neopixel ring. So I can kind of like barely fit them a little bit. Later on, I can twist the components to be you know, to fit really nicely. Okay, so you got that. I'll turn on the documentation layer so you can see a little bit nicer. So you can really see the components. Okay, so we're starting to kind of fill out this shape a little bit, which is pretty nice. Okay, so next up, I wanted to add sensors, and I was going to start with the accelerometer. So I won't connect all the pins for the accelerometer. Just, you know, that's a whole game in and of itself. So we're going to go with the list 3DH. And what's nice about this accelerometer is you can use I2C or SPI. In this case, I'm actually using SPI because I wanted to leave the I2C pins available. And accelerometers, of course, work best if they're in the center of the board. Okay, but the thing is, we're kind of like, we're really running out of space here. Like this is, you know, we're gonna have to fit all of, you know, the speaker, microphone. Like it's getting a little bit cramped. And remember, we have to route all the signal lines as well. And this board's gonna be a 2-layer board. So I can already tell by this stage, like, okay, I'm definitely gonna run out of space. So that's when I decided, okay, I'm going to make the board a little bit bigger. And I thought that was okay. You know, the Arduino and the Raspberry Pi are like, you know, they're fairly large boards. And I thought, even though you pay a little bit more for the PCB, I thought it was okay. Like, you know, especially especially since it's round, it doesn't seem much bigger.
Yeah, it's a neat trick. You really can't tell.
I mean, it is bigger. You know, it is bigger, but it doesn't seem that much bigger. In fact, you know, after playing with Circuit Playground, it feels much more natural in my hand. And the Flora seemed like small, but it's not that much bigger.
Yeah, we even went smaller with the Gemma in the past.
Yeah, the Gemma is really small, but it doesn't have all the sensors built in.
Yeah, and then we have Neopixel rings.
Yeah.
And those are different types of sizes of circles too.
I don't know if I have it.
Yeah, you do. You have one right in front of you on the shelf.
Oh, right, because I
Yeah.
bought this in case I needed it. So yeah, this is the
Yeah, I mean,
Neopixel rings. This is actually kind of closer to the Neopixel ring 16 size, very popular.
Yeah.
So it's not that much bigger. A little bit bigger, but not too much. And you get a little bit more spacing between the pads. Okay, so let's go in and we'll just make this a little bit bigger. So you've got this circle tool, and let's make the dimensions. Let's see if we can make it. So this was 0.875 radius, so times 2, you know, what's it called? 1.75. So let's make this 2 inches in diameter. So this is the size. It's only a little bit larger, not too much larger. And then we'll actually set the radius to be exactly 0. Apply. And the only thing is, if you set the width to 0, it actually fills it in. So you have to set it to be like a very small amount. And that's not too much bigger, but it gives us just enough space. So let's delete the old dimensional layer. And then, you know, we'll clean it up later, but basically get all the pads out. And you'll do this. You'll change your layout and your design as necessary to fit the components you want to fit. And it's not about making something small or large. I do prefer to have compact boards, but it's also about, does it look right? Does it feel like it has a good user interface? Because your circuit board has a user interface to it. And then we can move this up. And like, even though it was only a little bit more in the radius department, like, it really opened things up for us. So we can move all these components. And then don't forget your fiducials. These are little fiducials here. Those are handy when you go to manufacturing, you'll need them. So you might as well add them during the design phase. Add these little fiducial dots, because it'll help the machine locate the circuit board. It's part of the machine vision. Okay, wow. Look at all the space we've got now. So I ended up, let me see, on the final design, I actually put the chip very close to the USB port, and I got the accelerometer almost dead center, which is really nice because that way, you know, it can detect tilt. If it's in the center, it's going to be able to detect the full tilt of the board. Just you know, it's going to be more accurate if it's in the center. And then, yeah, we've got this switch, and I've got a little bit of a regulation circuitry going on over here and some capacitors. Okay, but we have like a ton more space now. Like, we're doing
Wi-Fi.
Much better. We could add a little Wi-Fi thing.
Add Bluetooth.
We could do that too. All right, so I wanted to add 2 tactile switches.
Make it a phone.
I'm going to add a phone. We're going to add a phone as like an add-on. So 6mm tactile switch. Yeah, one of these. I ended up, you know, I usually use ones with really big pads. So I'll place these down here and then kind of show it off. But, you know, I actually don't need such gigantic pads. So I'm going to I changed the package of these to be a little bit more compact. Because it depends on whether the legs on the package of the button go out or not. Okay, so we've got 2 buttons. That's looking pretty good. And also kind of get them as centered as possible. we got the slide switch. Okay, so let's put the sensors in. So I wanted to add a couple sensors, a thermistor, a light sensor, sound sensor. I got the tactile buttons and the slide switch, and the buzzer. So that's 4 items. And then I decided, you know, as I was laying this out, it seemed to me like I had kind of a little bit of space in these 4 corners to, like this kind of space in between these gaps is where I could put them. So let's go back to the schematic, and I'll add in the PT19 light sensor. And this this gets a 805 resistor. Oh, sorry. Because it acts as a transistor, you need to have, you know, a biasing resistor. If you can do some of this design stuff, like what components and how you're going to put them and where they're going to put them, if you can do this on a breadboard, it'll be a lot easier. So some of these things I designed little evaluation boards for, where I figured out like what's the best value is pull down or pull up better. I got that part working. So this is the light sensor. So I put the light sensor over here. And then, you know, I'll pick out the tracer later. What I usually do is I get all the components in the right location, because it doesn't really matter what digital I/O or analog pin you use. Very few pins are like super special purpose. A couple of them are, but most of them aren't. Even things like SPI, you can bit bang SPI. So having all the components placed where you want them on the circuit board, and then routing the traces and picking the closest pin. So of course, when I pick the analog pin to go to this phototransistor, I'm going to pick one from over here, not from over here, right? Because they'll just make my life a lot easier. I only have to pull a pin over here. And then likewise, for the Neopixels, the pin that's going to control these is going to be, you know, from over here. So I can make a straight shot over here and then have the data line go around. And then you know, the buttons, try to get them to come in from the corner. It's going to be a little harder for the components down here, but if you can, as much as possible, you know, try to pick the pins and place the components nearby. It just makes your routing a little easier, makes your life a little easier. Okay, next up we're going to get a thermistor. Now the thermistor is just an 0402 resistor. It's basically what it is. It's a resistor with certain, you know, thermal properties. So, you know, we'll call this 10K thermistor. And then it's on the right side. So I'll put this over here. Actually, I ended up picking a 603. So this is a thermistor. Those are the easy ones. And then I have the MEMS microphone. So let's see. No, it's called the SPW, yeah, silicon microphone. And the output of this microphone, unfortunately, does require an op-amp. So I picked it's not exactly this one, but basically I picked a dual op-amp to amplify and buffer. And there's going to be, of course, some passives that go with that, but we'll pretend like we'll do those later. So this is microphone circuit. Just kind of figure out where you want it approximately. And then over here we're going to put a speaker. In the first version, I ended up going with not one of these through-hole piezos. I ended up going with an 8mm buzzer. There's a little speaker coil inside. And then, of course, you'll need a transistor. One of these will do the job quite nicely. And then, of course, you need a diode as well, because it is a speaker. It's a coil. It's like a little inductor. pick a little diode. And then I'm not going to be driving this as a class A. It's basically just going to be pulsing up and down. So you just pick another resistor as an input there. And this one I kind of like, man, how did I fit this in here? I think I ended up like kind of pushing this out of the way, and then like this was over here, and then this got pushed down, and then this was over here. Yeah, something like this. There you go. That was kind of draft number 1. What do you think? Any questions so far?
No, I mean, like, how, just a couple questions is like, well, how do you know which side to put something on a board versus another side? Like, what are the reasons for some of this stuff?
Well, it's going to be round because, again, I want it to be round and wearable. So that kind of fixed that. And then, once you pick the side for the micro USB, I wanted to come up the top. I was like, well, where's the battery connector going to go? And I was like, well, it makes the most sense the battery hangs off. So it kind of only makes sense to go on the opposite side. So then, like, this part's fixed. Yeah. And then that means all the pads have to go symmetrically on the outside.
Yeah.
And the size of them is fixed by that alligator clip. Like, the alligator clip is a certain size. And so I was like, well, this is how big these pads are, and this is how many it can fit. And then, my budget kind of constrained what components I could put in. And so I tried to have as much symmetry as possible. So like the temperature sensor and the light sensor, the speaker and the microphone are on opposite sides. And then down the center, I have like the slide switch because it's an on-off. It's a symmetric component. Like I tried to have some symmetry to this. There's 2 buttons. And right now they're not symmetric because this is, kind of a mess. But in the final design, I made sure that they were perfectly symmetric, so it was left and right. Because I like symmetric design. Some people don't. Like, it would be fine to make this, it's non-symmetric as well. I just personally like it.
Yeah.
And then the accelerometer, I kind of you have to put that in the center because if it's going to detect tilt, it's best to put it in the center so it can.
Okay. Yeah, that was another question I saw was, when you design this, do you think like the pick and place machine vision system? I mean, you're like, well,
not as much as I used to. I used to think it mattered, and then as I did more work with the pick and place, I realized it doesn't really matter as much as I thought. I used to think like, oh, don't put these components too close to each other, or like give yourself spacing. But for the most part, you don't have to worry about that too much. I mean, obviously make sure that mechanically there isn't like a huge part next to, you can have huge parts next to skinny parts, but that means the skinny parts have to be pick and placed first. The flattest ones go first, then the bigger ones. But other than like some thermal requirements, like obviously don't put if you put something that has a lot of metal in it, like an inductor or a module with a metal tin, that's going to take a lot longer to heat up. So that might be a concern if you're putting it next to something that is very temperature sensitive, because you would have to heat up that area more, and that could damage the temperature sensitive part. This stuff is not, it's not that for makers, the kind of stuff that makers are doing. I don't see a lot of people cramming insane amount of parts. This is a single-sided design. Single-sided boards are going to be a lot cheaper than double-sided, because double-sided you have to go through the entire process twice. So your assembly costs are basically double, because your bill of materials is the same, but the assembly costs are double, and assembly costs are a couple bucks. So doubling it can make a big difference. If you can make your board single-sided and have everything be surface mount, that will reduce your cost quite a bit, or keep your costs under control. So that's why you see a lot of maker projects, surface mount only, and single-sided.
Okay.
Also means it's flat on the
next question I saw was, when you design a circuit board, do you think about the enclosure, or for this it didn't matter? For
this it doesn't matter as much, but in general, yes, you do have to think about the enclosure. In fact, you might want to have your enclosure designed at the same time as your prototype to make sure that if you're picking an enclosure that's a stock enclosure, like for example, the Zox box. So the Zox box kit used a default enclosure. This is an enclosure by PackTech. So PackTech manufactured an enclosure that looked like this. It was a desktop sloped keyboard box, and you could put a metal front plate on it. It was, pretty much perfect size. And so when you design the PCB, of course, we had to make it fit into that box. And so, the mounting holes had to be in the right location, the size. And so if you look at the design, it's actually, there's a lot of empty space in, there's a lot of empty space around here, like over here, there's a little bit of empty space. And over here, like it's not as cramped as it could be. Like over here, there's some space. Like there's definitely like, this isn't like the tightest packed PCB, and it's also a through hole. But because the PCB size was fixed by the enclosure, we picked components based on that, and that can matter for like potentiometers or buttons. They have to reach through the enclosure. The enclosure has to have like molded parts for it. So it is something you have to think about. As you're doing your design, your first design, don't worry about the enclosure too much. But as you're getting into your second or third prototype, you're going to definitely want to have 3D printed enclosure. For Circuit Playground, I actually thought that what we could do is use a clip, like a pin back, a sticky pin back, pin back sticker. See if I can find what a pin back sticker looks like. Whoa. Pin backing. I know, yeah, like these things. So, you can either solder these to the back, like I would have maybe a big solder point, you could solder it and then you could pin it, or you can get versions that are basically like this, but are stickered size, like this. And then you peel off the sticker and then you could clip it on. So that was kind of my idea for like, well, how are you going to make this wearable? You could also use a non-metallic chain or like a leather strap, and you could tie it through the big holes, and you could wear it as a necklace. Or you could sew it on. It's just like a Flora. You can sew it onto what you wanted. It is something that we're going to do. We're probably going to design an enclosure, but what we can do is have something that clamps over the edge of the board, because it's round. It's very easy to clamp onto. And I thought we would have something like a clamshell for it. So that's what I thought for enclosure. Something to think about though when you're designing how you're going to enclose it. For a lot of maker products, they don't have enclosures.
Yeah.
It's just
especially
a board.
for kits and stuff.
Well, kits they don't.
Okay, so next up, we've got plenty of space.
Okay.
We get the point.
Yeah. So now you actually do the routing, and I'm not going to bore you with that. So instead, let's quit.
The question always comes up is why not auto router?
Because the auto router will never give you the precision and accuracy you need. It's not going to be as smart as you. The auto router doesn't know when you can swap pins or when you can reroute things or like where things can move.
Yeah, so like AI and like all this computing power we have still can't do it.
It's just not a priority.
All right,
a lot of engineers.
Humans, you still have a job.
Yeah, we prefer to do layout. And so this is what I ended up designing.
Oh, look at that.
Let me turn on and off all these things. Sorry. Let me set the value color to gray.
It's like some science fiction city.
Okay, but this looks very similar, right?
Yeah.
This is almost identical, except now it's all the parts. Let me also turn on the documentation layer. Okay, and also it has all the values. And so what I've done is, I basically put all the components in the location. I moved things around a little bit, but for the most part, this is finished. This is the prototype. Now I did end up making a mistake or two in this, and that's fine. I forgot to pull up resistor here and there, and I ended up I used a transistor-based amplifier, and then I changed it to an op-amp later. For the most part, this was pretty much ready to go. Oh, another thing I did is when I designed this, I wanted to have a capacitive touch on all the pads, and so I ended up you need a pin with a 1 mega ohm resistor between the pin and the you have to toggle between 2 pins, and so I recycled that TX LED pin that was used for transmission LED, and I recycled that into using it to do capacitive touch. And so I have these. I couldn't actually fit 0603 resistors. I used a resistor pack. Check out resistor packs, capacitor packs. I didn't used to use them, but for the about the same cost of 4 components. You get 1 component, and you pick and place it at once, and it works great. But pretty much this was ready to go, and
then
we prototype it.
How do you look in the back of the PCB?
Well, here's what I do actually. So the back of the PCB is where I put the silkscreen, because remember I don't put components on it. You can hide layers, so I'll hide the top parts, and then you can see the bottom of the PCB. So you can see all the traces.
And how do you put graphics in? That's always a question.
That's a good question. Yeah, graphics you put in. There's a couple different ways, but the way I do it is you open up your library. Only thing is I don't know if I have any graphics handy, but maybe I'll be able to fake it. Okay, so you go to your library, and then you make a new logo package. And it depends. I mean, your graphics program will be, your CAD program will be different. And then you run BMP. Sorry, it's called.
We made a learn guide on this too.
I did, but boy, I can never remember it. It's the BMP converter, but I don't remember what it's called. Is it import? Yeah, import BMP. And then you have to select a bitmap. So for example, Rev B, the silkscreen was done as a bitmap, so we drew the bitmap. And then you select the color of the bitmap, and then if you do it right, you scale it so it's like 0.1 mil, 1 mil per, I don't remember exactly. You have to scale it. And then import it, take quite a while. But this tool basically will take it and it will raster the bitmap for you, and it'll say like, here's what I'm going to do, and you say run.
Wow.
And it imports it in, and you can tell it's actually made of like little lines.
So that's why it looks so good. Jeez.
Like little lines, but the lines are very, because there's no such thing as vector graphics in Gerber. All it does is like, it's only meant for like lines and rectangles. So it just takes thousands of rectangles and uses those rectangles to draw your design. But if the rectangles are very small, it doesn't matter. So this is where, this is how we get the logo nicely. We basically make an Illustrator, export it to BMP, bitmap, and then use the Eagle bitmap importer to import it in.
That was the number 1 question.
That is the number 1 question. And then you change the layer to be the T-place.
This was worth the price of admission right here.
Yeah. So that's not too bad. It looks a little rough, but again, the silkscreen resolution isn't so great, so it's like it's good enough, and it looks quite nice. So after you get your silkscreen and everything, I mean, I usually don't do the silkscreen till Web 2 or 3.
Yeah.
So now you have to generate Gerbers. So let's say, okay, you've finished your layout, and you're like, I think this is done. I prototyped some of this on a breadboard using the eval boards from before, so I think all the pinouts are correct. You're going to make mistakes, but try to minimize them. Maybe have a friend look over your design. Run the ERC, the electrical check. It will tell you about any mistakes it thinks. Like for example, it's like, hey, there's this VDD pin, but it's connected to 3.3 volts. It's a different name. Is that okay? D11 only has 1 value. Like that pin is brought out, but it's not connected to anything. And so is A2. It's not connected to anything. That's fine. These are, as you are picking what pins you want, not all of them are going to get used. In this case, Analog 2 didn't get used, AREF didn't get used, and because we're just going to use the internal analog reference, and D11 isn't going to get used. But whatever, that's fine. I'm going to leave them here. And then in your board design, run the DRC. And depending on what board house you use, there's going to be different requirements for how thin you can get the wires and how small you can get the pins and the trace width and restring. And there's all these settings. If you're not sure, ask your PCB house for their DRC listing, and they'll say, here's the minimum drill size, and here's the maximum drill size. Here's the minimum trace width and the distance. 8 mil is a very common distance. Of course, the closer the traces and the thinner the traces they are, the more you can pack in to your circuit board, but the chances of there being yield issues goes up, right? You're gonna have no yield issues with big traces and huge spacings. But if you're going down to 4 mil, you know, it's going to be more likely that you're going to have errors. It might cost you more for the PCB because the PCB house has to do a much higher quality job. So it might take more checking, more testing, you know, more analysis. And then run the DRC check. In this case, I approved every error, but there are a bunch of errors that came up. For example, it doesn't like that I have these pads up to the edge of the PCB. Personally, this is fine, but it's confused. It's like, are you sure you want that? Most people don't want.
Normally, that's not normal.
Yeah, they're like, you don't want the component up at the end, but
Yeah,
I
that's
do.
weird.
So I approved it. There's a little bit of clearance here. I know why this is. It's some of these DRCs errors you're going to get are side effects of the way the CAD program runs. Like for example, I get a lot of errors because I have slots. You know, as I draw slots by basically having a drill hole and then drawing a dimension layer around it, and that's how my PCB houses do slots.
But that shows up as an error.
But it like EagleCAD flips. It's just like, what are you doing? There's a hole there and there's a dimension. Like there's no good way to implement a slot. Sometimes you have multiple drill holes that are in a row. There's like it just kind of wasn't a thing that was well thought out in Eagle. I mean, it was well thought out to the extent that it could. It's just not very elegant. This works quite well, but so there's a lot of DRC errors. Yeah, some overlap because I'm abusing this ground plane, which is fine. Some complaints about the width because even though this is a solid chunk, the width of the line is short. Yeah, whatever. None of these are showstoppers, but watch out. Sometimes there's like, you know, wrong traces, wrong paths.
Does it help you? Does it catch stuff?
Yeah, go through all of them. But some of them I know, I'm like, oh, the oval thing with everything we do with micro USB, I always have like 90 errors because it complains about the oval shape. It doesn't like it.
All right.
But,
okay.
you know,
so
check it.
You took a look at the errors. You know about them, why they're doing it.
Yep.
Doesn't matter. And what happens
Okay,
now?
so you do the ERC, the DRC, and go through and clear those out. And then make sure your rat's nest has nothing to do. Make sure that there's absolutely no traces. Like, because as you're doing ERCs and DRCs and you might be renaming things, air wires can creep back in. I've seen people get burnt. Luckily, I don't think I've ever had an air wire issue because I'm really neurotic about it, but other people I know have had it. So just check to make sure that there's absolutely no air wires. And then you're going to generate Gerbers. And every program is going to be a little bit different. In this case, I run the Exelon, which is the drills. Drills are generated separately. So Exelon drill is a standard drill format. And then I run the Gerber tools, and it goes through and it basically generates a layer for each version. And then once I'm done with that, you can use software. So these are the Gerber files that got generated. And Gerber files they're just text files. You know, you can actually open them up and look at them. It's just a description.
It looks like circuit playground.
Yeah, it's just like, you know, blonde, brunette, redhead. You know, it's like you can kind of see, but sometimes you will. Like for example, for drill files, you can go in and edit drills, and I have done that. I have like, rather than like going through and editing all of the vias or something, I'll go in and I'll tweak the drill file. It's not recommended, but you can do it. I've done it. And all of these drill files, the Gerber files, you can view with a Gerber viewer. And so like I use, GC Preview. There's hundreds of free Gerber viewers. You can pay for them. And then you can import the Gerber files. So let me go to this location. So let's import the dimension file first. And it'll be like, I found this dimension file, and I'll complain, and I'll tell you what color, and then you can see this is the dimension file. Okay. So this is just that. What I suggest is you import every file in order as it would be layered up, because that will help you analyze what's going on. Like for example, all these holes are in the wrong location. That's a common thing that comes up, but it's because this Gerber viewer does 3 precision, and I want 4 precision. Okay,
there,
so
now fixed it.
No, I fixed it. So now that holds up here, because there's the leading 0. It doesn't know, and watch out for like millimeter or inch variation. Make sure you have the right. you can, down here, there, it tells you, the size, and so you can measure, make sure you have everything in the right size. So let's do the top layer next. And then I'll have this color be a different color so it stands out. So you can zoom in and really look, make sure that all your things look good. You'll notice, I actually will catch things that I didn't catch in EagleCAD because I'm looking at just one layer at a time. So I'll see sometimes things that I normally wouldn't have seen. Like, this is a trace that's missing.
Machine is going to, one of the questions was, is this what a machine is going to drill out? Is this what it's going to mill out?
This is going to be photoresisted out. And there's video guides about how that works. But basically, it has a UV light and a mask, and it flashes this. It's like a silkscreen. And it flashes this onto a photosensitive copper and then etches it away. You can also etch your own circuit board. You can use it like the other mill that we have. Something a small circuit playground.
Yeah.
Not so good but for bigger parts, you can etch your own PCBs. The first Minty Boost.
Yeah, we made the Minty Boost
We
together.
etched by hand, yeah. So next up, let's do the
That's
top.
back when you kept a vat of acid next to your bed.
Yeah, that was so romantic. So this is the stop layer. Another good thing to check, make sure that you have a stop layer, like for example for ground plane, for center ground pads, make sure you have a stop there. All of the pads around here, if you're making custom components, make sure that you have a stop layer. And then, they'll look good. The pads look nice and square. And then let's import the top overlay. And then we'll import this in black. And then, you can see where the silkscreen is going to be. It's also good to check. This is a little bit tough to read. Maybe I'll make it blue. Okay, so now nice and clear. So you can see all the silkscreen. Make sure that the silkscreen doesn't interfere with any of the pads. You want them to not overlap. I mean, your board house will fix it if it is, but it's make sure all the text is readable, right location, all that good stuff. And then finally, the cream layer, that's where the solder paste will come in. Not important for the prototyping, but if you have this as a mistake, it will bite you later. It's harder to fix later. So make sure that where the solder paste will go. Like for example, on ground pads, you don't want full coverage because the pad would make the component float. So instead, you put like 6 little dollops, right? Otherwise, it's too much paste.
And we have a machine that does this at Adafruit.
Yep. So when you get the stencil manufactured, you can just give them this file. And again, if there's a mistake in it, you can edit it after the PCB is made, but before the stencils are ordered. But it's very
and
icky.
they're cutting sheets of metal with a giant laser.
Yeah,
too.
you want to make sure that this is right, and so you'll see the paste is just a little bit smaller than the pad. That's normal because you don't want it to bridge. So check that out, and note we have paste on all of these pads, but those the alligator clip pads don't get it because you don't want that. It's exposed copper without a pad, so you have to kind of edit your packages in your CAD software to put paste where you want it and not where you don't want it.
Yeah.
And that in of itself it's a fun game. Here I have.
I can see why you like video games. You're like, this is like Minecraft times a billion.
Little paste everywhere, not paste. And then what I also like to do, so you can look at the bottom later. Another program I really like to use is called Zoffs, but it's actually called 3D Gerber Viewer.
Okay.
I don't know why. And what I really like about this software is it gives you a 3D model. The only thing that's a little weird about it is it has a very funny interface.
Yeah, this is the weirdest UI.
I know, it's a little bit odd, but you know what? It's so worth it. And I actually already programmed it to tell it what I name all of my components, so it knows
it's like what computers used to look like 30 years ago. It's like, this is the future of the
This is so like system. Next Step, yeah?
No, I think Next Step was
Atari, Amiga?
Yeah, this is what computers will look like in the year 3000 in like 1960 videos.
Yeah, I found that there's some good software that I found lately that has very unique
I want to see what this turns
UI.
this thing into.
Anyways, it will automatically detect what the silkscreen, solder mask, copper. You can customize it, which I've already done. So it has the Adafruit rule. So the name of the file, it detects it, and then what's neat is it will do a 3D rendering for you. And I actually love this. This is like my favorite thing to do, because that other software, like, it's very technical and you can like drill down with each layer, but this one gives you like,
whoa,
you know, a beautiful 3D model, and you can
they're not into modern UIs, but this is like 3D. It's like, whoa, man.
Yeah, and
this is like really, Oculus Rift. We're in space.
Yay, I'm floating, I'm in, I'm going in.
Whoa,
too close.
This is my favorite part of
too
that
far,
movie.
Too close.
Okay.
So this is really great because it kind of gives you a very visual, like if you're missing, it's not going to be as easy to tell if you're missing like a drill hole or a component, whatever, but it is really good for, you know, is my paste on the right location? What's my silkscreen going to look like? It doesn't render the component, but honestly, I think that's fine. Like there are ones that render it, but I don't need that. I'm just trying to see, like, is there anything I'm missing? You know, you can kind of get a sense of what it's going to look like. You know, that these pads are all the way around. They don't have paste on them, and this is correct, and then this is fine, and then everything's labeled. It's just a lovely thing to do. So now that we've done this, you know, also make sure, like, okay, did my bottom pads, make sure that there's no mask over them, and then, you know, I ended up having FCC certification, so I put the logo on the back, and this is Rev B, as you remember. So this looks pretty good. So I'm pretty happy with this. And so let's get prototype PCBs made. You ready?
Yeah, I want to see what's going to happen with this.
Okay, so for prototype PCBs, I recommend going to OshPark because they support open source hardware, and also they're just like lovely, lovely people. And
yeah, Lane's
great.
Was on our hardware hangout show a really long time ago.
Yeah, I really dig it. So I logged in, and so you can go to your projects. It says, okay, you have to upload something and then get started now. And then what's really neat is you can actually upload just the BRD file. So let's try that. So you can just like drag and drop it, which is like amazing. And give it a second because it actually like generates the Gerbers for you. Like I think it's actually running a copy of EagleCAD in the background to generate.
Oh, really?
Yeah. So give it a moment. Okay. So when it's done, it'll give you a rendering, which looks very familiar. This rendering of your circuit board.
Oh.
The only thing is that it puts the component names down, and I actually prefer that it doesn't. So even though I could continue with this, I'm going to upload the Gerber files themselves. So you create a new zip file, and then put your revision notes, drag this here. So now you have a zip file, and then drag the zip file over. And then of course, you know, if no matter what PCB layout software you're using, you'll be able to, I can't find a board outline file. Okay, it wants a different name for the board outline file. So let's rename our file. It wants, because like the ending of the name, so GTL is the top layer, that's correct. BL is the bottom layer, that's also correct. BSTOGO, oh, so outline is not dimension, I call it dim, it should be called GKL. Yeah. And then toss that in. And then drill should not be called DRD, they should be called XLN. That's fine. So we renamed that file. Let's go back and try again. Processing. I think we're gonna get to the processing stage. And what's neat is it'll also give you a quote. Okay, so now, yeah, it looks a lot cleaner. If I had any more silkscreen, that would show up, but this is pretty good. I'm digging it. And this is, you know, Circuit Playground Prototype Rev A.
So someone pointed out something that I had heard before. So the rendering, when you look at Circuit Playground,
Yeah.
kind of looks like Twiggy from Buck Rogers,
Oh.
but not Twiggy the robot. Twiggy wears Dr. Theopolis. So Circuit Playground,
Okay.
yeah, I got mentioned a couple times. They're like, that reminds me of.
Okay.
Look, because you did the renderings and this
Yeah.
is what happens.
Okay, it's a little purplish. Okay.
Yeah.
All right, so we continue. Okay, so it detected a 2 by 2 inch board. Now remember, even though it's circular, you're going to pay for the whole square shape. It's going to be $20 for 3 boards. That's pretty good.
Not too shabby. Thank you, Lane.
Thank you, Lane. Other PCB houses that I used to use, you would pay at least, you had a minimum order of like $300 or $100. So $20 is a sweet deal. So let's continue. And it's like, okay, look to make sure, you know, black is all the holes, and that's correct. Drill holes, it looks good. That looks good. Gold, copper, purple mask. Yeah, it's purple. All the PCBs are purple. And then, you can't quite see it, but I think this is fine. I'm not too worried about this. This is the bottom silkscreen, top solder mask, top layer.
So they kind of do what that program does and breaks it out.
Yeah.
And have you like look at everything.
Yeah,
It's
this
like,
is a
look,
Gerber
you gotta
render.
approve.
Yeah, are you sure?
Yeah, are you sure about all this? Okay.
Okay, approve and order. And then this is when you would check out, because it takes 3 weeks to do this, up to 3 weeks. You can pay for super swift service. So I don't know what that does. I guess that gets you, wow, under 4 business days, but you have to pay a little bit more. But we're
It's
not
not
in a
bad
rush.
at all.
So checkout, and this is
Yeah,
where
I
you
can-
would put in your payment information, how you want it shipped.
Yeah.
You can order teensies as well, and then order it, and then you will get
Well,
a
that's
PCB.
neat. Can you scroll down? I just want to see this like upsell.
Yeah, this is an upsell.
You'd like to order a purple teensy on your way out.
They have purple teensies. What a bargain.
Huh.
Okay, and then let's see if I have a prototype. Yeah. So what you'll get when you're done, can you go to the overhead? Is a PCB like this. Purple PCB. This is not from
That
Osh
was
Park.
instant.
I know. That was a super swift. But you'll get these purple PCBs, and you can get started, and then, you know, you've ordered all your components. So you've ordered little strips of parts from, like, for example, DigiKey. I got these resistor arrays and some thermistors, part NCP15X103F. So all these parts come on little strips of tape. I got the little speakers. Looks like a little Pez dispenser type thing. All of these come on little cut tape, and you can solder them by hand. We'll be doing that in the next episode. So there you go.
So that's design. All right, so just to recap, what's coming up soon. So concept, research, evaluation, design. Next up is going to be prototyping.
Yeah. That's going to be fun. I'll probably not actually do the soldering of the board. Maybe I'll do a little bit, but I'll show how to do like the bring up of the board and testing out every component. We'll see what's the best. We'll think of something. Every week we think about it until we do the video. But that's pretty good. We did about an hour of layout.
Yeah, that's
talking
cool.
about all the things that you're going to do as you do your circuit board layout. I mean, circuit board layout is something I've been doing for a really long time, and so there's a lot of things that are just natural for me, but it is a fun game to play.
Number one question was how to get the graphics on the PCB, so good work.
I know.
No, it's a big question.
It's always the tough question.
All right, well, we'll see everybody next week. And thanks for watching.
All right, thanks everybody. See you next week.